Well, differently from the majority of my videos, which I consider tedious exercises, this uh, explains the in a plausible way the nature of the natural numbers, and I think it is relevant and original. But one must follow the argument. First, trope theory and natural numbers. Summarizing what I intend to do, I wish to develop a strategy to show how natural numbers can be understood as tropical, spatial-temporally localizable entities. But first, I need to say something about tropes. Trope theory is an ontological theory aiming to build the whole world based on building blocks called tropes. If you are dissatisfied with the Platonic and sub-Platonic, that is, the Aristotelian ontological theories, and also with the diverse forms of nominalism, then try the trope theory. My characterization is tropes are spatial temporally localizable properties. Well, also material objects are spatial temporally localizable properties. So uh, this is not enough, but this is something that the tropes must have. And this definition or characterization disregarding the degree of vagueness. This means that, for example, the electromagnetic field of the North Pole can be considered a trope or something constituted by tropes since it is a spatial temporally located property of the pole, even if in a very diffuse way. That is, you have the North Pole as the reference of the subject and the reference of the predicate, the electromagnetic field of the North Pole, is the trope or tropes that constitute the electromagnetic field. Uh, the goal of the pure trope theory proposed by Donald Williams in 1953 was to use these properties as the ontological building blocks of the world, allowing the construction of universals as sets of precisely identical tropes and material things as compresent tropes. And this, this was new because although the idea of spatial-temporal localized properties exists at least since Aristotle, no one had uh, the idea to use them as the building blocks of the world in an ontological sense. This is totally anti-Platonic. This is the reversal of the Platonic perspective. Well, here is a sentence of Williams. Any possible world, and of course this one, is completely constituted by its tropes. Examples begin with quality tropes, like the red of that table, its hardness, limiting tropes like the rectangular shape of the table. There are possibly relational tropes like the trope of the aboveness regarding the bridge above the sea water, uh, including tropes of causality between me and this computer, for example. Uh, if you take trope theory seriously, then these things must be at least vaguely located where these things are. Quality tropes can obviously be seen or heard or touched, and at this level, one can easily prove their existence. If you look at the ocean, you can pay attention to the movements of the waves, or you can pay attention to their colors or their sounds. Tropes are objects of selective attention, as Michael Lux has noted. So, uh, here is a photo of the waves, and they can together uh, form complex tropes you can add. For instance, the Fifth Symphony, when it is being when it is played, it is homogeneous, a common or a combination of homogeneous tropes, all tropes of the same kind, sounds, and the orchestra is the object that plays the symphony. The symphony is a process, property process that is that is linked and dependent of the orchestra when it is playing it. Another example, the 30 Years' War. These are an extremely complex combination of heterogeneous tropes, including psychological tropes, since the people struggling had minds and were not mere robots. Well, this occurred as a process, as a property process, uh, but where in some countries of Europe, and these countries can serve as the object referred by subject, and the predicate refers to the 30 Years War. That is the property dependent of these countries, the existence of these countries. I think that what distinguishes essentially the tropes from the objects is that the tropes are dependent of the objects within the fact, that is, in the scope of the fact. And you can choose differently. You can say that the 30 Years' War was a catastrophe, but then the property of being a catastrophe is of the 30 Years' War, and the 30 Years' War is an object as a combination of tropes, well, to a certain extent, compresent and enduring in time, and have the properties of an object. So, it is a relative thing, but this does not mind. Material objects are said to be combinations of compresent tropes, and so on. They typically have a nucleus of fundamental kernel tropes and contingent halotropes. This is an idea defended by Simons. Solidity seems to be essential, and I guess that inertial mass is particularly important here, though not open to direct experience. It's not necessary that a trope is open to direct experiences as far as it is a spatial, temporally localizable, and it's not an object. is not dealt with as an object. Properties like physical forces would be constructed from more directly expressible tropes. Campbell would call them quasi-tropes, but I see this as a prejudice. I call them tropes simply because they are also spatial-temporally located properties. And both Williams and Campbell construct universals as sets of precisely similar tropes. A problem for the trope theory is how to explain formal entities like those of mathematics, which do not seem to be constituted by tropes. My intention here is to show a way to build natural numbers from tropes. This would be the best starting point since natural numbers are the touching stones of mathematics. However, since we treat natural numbers often as universals, I begin by explaining how I think that universals should be much better constructed out of tropes than with the old and old-fashioned help of sets. The usual strategy is to construct the universal as a set or sum of strictly similar tropes. This was the strategy of Williams and Campbell. The universal redness, for instance, is the set of all tropes of red that are strictly similar one another. Here is tentative of representation. The universal is a set of strictly similar that is qualitatively identical tropes. The similarity must be here transitive, and it will be transitive only insofar as it is qualitatively identical. However, this answer has well-known shortcomings. The first one, some consider sets abstract entities, that is, universals in the Platonic or subplatonic senses, but this is what we wish to avoid. Second, there is a well-known problem concerning our treatment of strict similarities. Either they are instances of the universal of strict similarity, what does not help, since it allows two abstract universals when trope theory seeks to eliminate them, or they are also tropes. If they are also tropes, however, then two couples of strictly similar tropes must have a strict similarity between them, which would be a second order similarity. It is easy to see that we would soon need a third order strict similarity of second order ones falling into an infinite regress of higher order similarities. Third, a further problem is that sets can change the number of its elements, what means that sets of strictly similar tropes would easily change their size. Most of these sets seem to be, in fact, growing. However, universals do not have sizes. One could suggest that one could build an universal as an open set of strictly similar tropes, a set in which the number of elements remain undetermined. But an open set exists as something in our minds or papers, but does not seem to exist as something in the world. However, the universal constructed out of tropes must belong to the world, to the ontological domain. We are doing ontology here. and sets belonging to the world seem to be always closed, having a determined number of elements. You can count the elements of any set uh, of elements belonging to the world. Uh, Ideally count. My way to deal with the problem is simpler and inspired in the particularism of the English empiricists. Instead of appealing to sets, I suggest that to build universals, we proceed like a geometer building a proof by means of an example drawn on a blackboard. The example serves as a model for all cases. This is an idea that you can find in Berkeley. For example, the sum of the internal angles of any triangle is 180 degrees. And you have this proof, and you don't need anything more. You know that this proof will serve to any other triangle. Well, this suggests that all that we need in order to construct a universal is one only trope that we use as a model, normally represented by means of our memory. Then we define the universal as either this model or any other trope that is strictly similar to this model. More precisely, calling T mu the trope used as a model and T any other trope strictly similar to T mu, we can define universals by means of tropes as follows. The universal for a trope T, by definition, is T mu or any other trope strictly similar to T mu. I understand strictly similar, as I already said, as another word for qualitatively identical, namely the identity between two different located things. Given a clear example, suppose I am acquainted with a patch of vermilion of cinnabar, a very specific color. I think it is this color here. Now suppose I intend to use some trope of vermilion of cinnabar as the model trope V mu. This allows me to build the universal of this color as the trope V mu or any other trope strictly similar to V mu. Certainly, V mu is in practice does not need to remain the same. You can do the same using any other patch as a model. That is, the models are freely changeable as far as they remain strictly similar. It is willkürlich. Moreover, we are also free from the urge of building higher order strict similarities, since we consider any chosen trope T by its first order strict similarity with T mu, or by its lack of this strict similarity. That is, the models are freely changeable as far as they remain strictly similar as T mu's in the schema. You have here a T mu and here a T mu that you are using as a model, and the others that are strictly similar or qualitatively identical. Usually, we use the memory in order to do this, but this is not the real point. We can imagine people without color memory going with small tables with patches of vermilion of cinnabar, serving as models of cinnabar in order to compare and to see if what they find is identical with those models. Well, here they are. The next point is uh, applied natural numbers. We need to explain what are applied natural numbers, and it is easy to understand them as tropes, as second order, higher order tropes, and then we will use the same method to uh, generalize producing abstract or general numbers or numbers in themselves.